When students are given a quadratic function in standard form, sometimes it's very difficult for them to be able to change back to vertex form by completing the square. So another method or option that you might provide for students is when you're trying to find that vertex hk for the vertex form, one way would be to find h using opposite of b over 2a since it's in standard form to begin with, and k is just going to be f of h, or whatever you find for h, you're going to substitute back into the function. So once we do that, if we have opposite of b would be positive 4 divided by 2 times 2, and so 4 divided by 4 is going to be 1. If we go back up to the function and find f of 1, because f of h, substitute 1 in for the x's, we're going to have 2 times 1 squared minus 4 times 1 plus 5. And then you're going to have, it's going to be 2 minus 4 plus 5, and that's going to be negative 2 plus 5, which is positive 3. So the vertex is going to be at 1, 3. And then students can use the formula for vertex form, y equals a times x minus h squared plus k. You already know that, so y equals a, h and k are the vertex, so x minus 3, minus 1, since that's the x coordinate of the vertex, squared, and then plus 3. Well, you still don't have one part of the equation, which is a, and to be able to solve for a, to create one unknown, you need one point that you know for sure is on that parabola. And these are equivalent forms. I'm not changing what the parabola is. I'm just writing it in different forms. So if I use the original function, and that's in standard form, and I substitute 0 in for x's, you can easily see that the y-intercept would be 5. So 0, 5 is a point on that parabola. And so you can say, okay, then 5 equals a times 0 minus 1 squared plus 3. And now you can solve for a, so that's going to be 5 equals a times negative 1 squared would just be 1. It's an equal sign right there. And then plus 3. And then 5 minus 3 would be 2 equals a. So if a equals 2, the entire equation in vertex form would be y equals 2, and then now you just put your x and y back in to represent every point on the quadratic function. So x minus 1 squared plus 3. And that would be your final equation in vertex form, which may be easier for some students than completing the square.